Let's do one last example, and this is the hard version. So this is trig functions level 3. And notice that this particular function throws two curveballs at us that we need to be aware of. Okay, the first one comes when we're calculating the period. So as always, our process for calculating the period doesn't change. We care first of all about the frequency, which is 1/4. So we're going to take our 2 pi and divide it by the frequency. So now we have 2 pi divided by 1/4. Now how does that work? Right? How do we divide by a fraction? Well, remember this. Dividing by a fraction is always the same as multiplying by the reciprocal of that fraction. So when I multiply by the reciprocal, that means I take it and I flip it upside down. So if my fraction is 1/4, the reciprocal of my fraction is 4/1, which is really just 4. All of which is to say 2 pi divided by 1/4 is the same as 4 times 2 pi, which should equal 8 pi. Okay, so don't be thrown off by that. Just remember your rules for multiplying with fractions. In any case, our rules remain the same. I'm still going to type in 8 pi as the period. What's the amplitude and what's the midline here? We should think about that before we set the y scale. The midline is 0 because we don't see any number being added out to the side. What is the amplitude? The amplitude is going to be 1. Again, we don't see any number out front. Therefore, we know we need to treat that as 1. We can't just treat it as 0 because otherwise the whole thing would be. Our amplitude is 1, our midline is 0. So the highest value we'll get to is +1, and the lowest value we'll get to is -1, which means that we're safe to set the scale at 1. Okay. Now, what is the other curveball that we need to be aware of here? We need to pay attention to the fact that this particular function has a negative sign out front, right? So instead of our normal fraction, or excuse me, our normal equation, we now have a negated version of our trig equation. And what does that do to our function? Remember that what that does is it flips the function upside down, or it reflects it across the x-axis. Flips it upside down. Okay, so first of all, let's fill out our other things. We know our maximum value is +1 and our lowest value is -1, right? So this will still be our maximum and this will still be our minimum. Now, this does not change the basic contours of our shape. It doesn't change our pacing, right? We should still be good to take this dot for the period and set it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're still good to do all that stuff. But here's the real consequence of this fact, right? When we have our function flipped upside down, it's not going to change where our function crosses the midline. That's going to stay the same. What it does change is whenever we previously reached a maximum, we're now going to reach a minimum. So where cosine reaches a maximum, it will really reach a minimum with the reflected version. Right? Where sine reached a maximum, it will now reach a minimum in the reflected version. And vice versa, where it previously reached a minimum, it will now reach a maximum, meaning a high point. Right? So in other words, a flipped upside down version of cosine is going to start at the bottom when x is 0, reach the midline at the same point as always, and then continue to the maximum, come back down to the midline, and end at the bottom where it started. That's the only thing that changes. So now we can kind of go about this in our normal way. When x is 0, we're still at one of our extremes. The only difference is that now we're at the bottom. So when x is 0, we're at our minimum. So we're at -1. 4 grid lines in, 1, 2, 3, 4, we're at the midline, which is still 0. 4 grid lines past, we're now at the maximum. 4 grid lines past, we're back at the minimum. And then when we reach the end of the period, we're back at the bottom. Again, we still get the same exact shape, just notice that it's flipped upside down now. That's the only thing new, right? And once we do that, we are good to go.